SME program that I was driving. We do have an iconic leader program that I'll be joining, and my ex-manager Aarti Sankhe, she is a seasoned leader. She would be taking up that session. She would be talking about her journey and her challenges being a woman, right? So hoping that you all will join and get inspired from all the good work that she has done over last several years, right? So this is more on the technical side. That would be more on the motivation and learning from other people's journey side. So let's get going with today's session. Today I'll focus on the application security area, right? I have extensively worked on application security. I have worked on network security. I have worked on cryptography. I have worked on various other like client side security, building protocols. But application security is one area that I like the most because the whole versatile kind of activities that it involves, that's massive, right? And that is directly applied to software, right? So we'll touch base largely on the application security today. This is what I have on the agenda today. We'll be doing a very quick recap of the last session. I'll not spend a lot of time because this is the last session on the technical aspect. I have a lot of things to talk, and I think I've asked you people to have Burp Community Edition installed. So that would be just a 10-minute session. Even if you're not installed, that's perfectly fine. You can learn whatever I'm talking about, and that learning also should suffice. Right. So we'll do a quick recap of last session, then we'll focus on the application security areas, secure design, secure coding. Then we'll talk about the different SDL activities that are there. We will do a quick exercise on adversarial thinking and some basics of application proxy, and then we'll go to basics. There would be a quiz, definitely, so that quiz will come in between. Okay, so let's get going. Let's do a quick recap. CIA, we have spoken so many times, so I'll not go a lot detail into it. Confidentiality is keeping things confidential from access or viewing by unauthorized party. Integrity is keeping data from unauthorized modification. Confidentiality is more of a view or access. Integrity is more about modification, right? Availability is making sure that whatever software system we have built, that is available all the time and it doesn't go down. Access control framework. So authentication is all about identity. Authorization is that, okay, you have identity, what privileges, what permission you have. That's all about authorization. And accounting is keeping a track of things so that nobody can repudiate or deny doing something. So accounting is more of a monitoring and logging. Essentially logging, keeping a track of everything so that later it can be referenced and monitored, right? Principle of least privilege, we will talk a little later also because that's part of application security uh, curriculum that Infosys certification has, fundamentals of application security, but essentially giving as minimal permission to somebody, right? And as an analogy, you can see that within a house, you could have a maid or cook, but you do not give them access to your locker, right? Because you maintain principle of least privileges at your home. Same thing has to be applied when you develop a software, when you are maintaining a infrastructure, right? As a DevSecOps or a system administrator, across all the roles in the cybersecurity, principle of least privilege is important. And within an organization as well, when you join an organization, be it a software company or any organization, they follow RBAC, role-based access control. Depending on your role, you would have more access. A manager would have a different access compared to a person who's reporting to a manager, right? So role-based access would be applied across all the softwares, be it Workday or leave management. An employee who applies for a leave, he should not be able to approve his or her own leaves. That is a role that is assigned to a manager, and that's what is RBAC or role-based access. Right. So remember, principle of least privilege needs to be honored, followed across all the software implementation. We spoke about spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. This largely stands for STRIDE. This is a model that Microsoft coined, right? Spoofing is somebody trying to mock or mimic your identity. I take up all your pictures on Facebook or WhatsApp and create an account with your profile picture and make it look like that I am you, and send a friend request to all your friends and saying that my previous account is hacked. So that's more of a spoofing of identity. Tampering is modification of data. So I take up some of your data or some of your picture and use Photoshop and use it for some purpose that is malicious. Maybe proving that you were playing a casino game or drinking alcohol by tampering around with your picture and portraying you in a bad light. So that becomes a tampering example. In software world, it could be tampering the input, tampering the settings, tampering the URL parameters to do something that you're not allowed to do. Repudiation is more of denial of doing something, right? So I order something from Flipkart and say I never ordered. This is, and I keep annoying them, keep troubling them out. So they should have a way to stop that from happening by keeping a track and log of all my events. Ability to prove that this originated from my login, my system, this location, right? That's what is repudiation. uh, that's it, non-repudiation. Repudiation is ability to deny that you did something. Non-repudiation is that you don't have ability because the publisher of the software or the vendor is doing good in logging and monitoring. Information disclosure is leakage of something sensitive, right? So inadvertently you leak your password to any account, that's more of an information disclosure. Denial of service, an example could be that I lock out your account and you're not able to access it at a time when there was a good deal running on the website. I block all the users and I go ahead and do the purchase. So that benefits me. Or kind of launching a denial of service attack to degrade the service. Elevation of privilege, gaining ability to do something that I'm not allowed to do, right? So I work in an organization. I also have a manager. I do something and approve on my manager's behalf and able to do that out. That's more of a elevation of privilege, right? I plan a travel, say to Singapore, all of a sudden and call it as a business trip and go ahead and approve on behalf of my manager, and it goes through the approval, and that's what would be more of an example of elevation of privileges. So I'll not go a lot in detail of that. I'll just keep moving. Risk evaluation, remember that has a lot of parameters, but two key parameters are what is the likelihood of an attack and what is the financial impact due to the attack, right? If something goes wrong from a security vulnerability impact perspective, how likely is that going to happen? Is it just one time, one of the case, right? Or is it likely that it will keep happening? And how big is the impact? If it happens, how how much are we going to lose the money, right? There are other factors also like frequency, security measures, environmental context, right? So I'll not go through a lot in detail because we have already discussed all this. What is the value of the asset, that also comes into picture. Threat, vulnerability, exploit, risk, all are different terms. Threat is like something might go wrong, right? You create an account on any web server or a web application, e-commerce website. The threat is that your login credentials could be compromised, right? They may get compromised because of you or may get compromised because of a breach at the end of the e-commerce vendor, right? From your end, it can get compromised. Suppose that you create the account and you write the password and keep it somewhere. And from the vendor side, it can get compromised if they're accepting weaker password, if they're not keeping the database protected, if they do not have multi-factor authentication. That all could lead to a compromise. But again, threat is likelihood. It's not a vulnerability. It's not an attack, right? Threat is just a threat. Whether it really gets materialized, that will depend on the mitigation that is built in the system. Now, moving to vulnerability, vulnerability is a weakness or a gap in a security program that can be exploited, right? So threat is likelihood, vulnerability is okay, this is a weakness or gap in the program, right? And it's confirmed that there is a problem. So while threat was more of a likelihood, vulnerability example I can say for the same e-commerce website that they are accepting weak password and they do not have multi-factor authentication. So your account could get compromised. Exploit is a set of step or a POC or a script via which a given vulnerability can be exploited, right? You can write n number of different scripts, but and at any time whatever script or a POC you are using to exploit a vulnerability, that's what is called as exploit. And the overall risk is what is the impact from vulnerability or getting exploited, right? How bad is the impact? So that's what is risk. That how big would be the loss. So that would be definition of risk. We also discussed about symmetric versus asymmetric cryptography. So I'll just quickly touch that symmetric key uses just one key. Remember, it's symmetric. So encryption and decryption will use the same symmetric key. Asymmetric, the name itself says that it is not symmetric. So it will have public and private key pair. Symmetric key is also called as shared key because the same key is shared both for encryption and decryption. Asymmetric key is called as public key cryptography because it involves public and private key, right? It is not called as private key, it is just called as public key cryptography, right? And you use a pair of keys, one for encryption, public key, and one for decryption, the private key. Speed of symmetric key is faster, right? And the usage is like routine data transmission where speed is essential. That's where used. The key exchange in case of symmetric key is a challenge. In case of asymmetric key, the public key is known to everybody. Private key is kept protected. So people can, to send the data to you, they can use your public key to encrypt the data, and you can use your private key that is only known to you to decrypt the data, right? So both kind of complement each other across various applications where they are used. Uh, I'll quickly run through all this. Symmetric cryptography, as you can see, the same key is used to encrypt and decrypt, right? The examples are AES, 3DS, Blowfish, right? The challenge is key distribution. We discussed scalability because with more number of parties involved in an encryption, you can see that the number of keys will increase, right? And the number of keys required for symmetric cryptography would be n into n minus 1 by 2, right? So in this case, it is two people that are interacting, right? So in their case, you can see 2 minus 1 is 1, and it will be just like one key seems to be good enough. But the moment you have 10 people, it would be 10 into 9 by 2, which you will require 45 keys, because for each of the parties, you would require a unique key for each side communication that you are doing. Key can get compromised, and repudiation would be difficult because you're using the same key for encryption and decryption. Now, Bob says that I received a message and it is encrypted message. This is the message, but he himself could have encrypted that message, right? Instead of Alice sending that out. So the repudiation becomes problem because the key is known to two people. So a compromise also could happen either from here or from here, right? Either side. So it's not confirmed that, I mean, whether Bob really himself encrypted that message or did it really came from Alice. So repudiation would be kind of available here, and non-repudiation would be hard to prove here. Okay, moving on to the next slide. Asymmetric cryptography, as you can see that there are two keys involved. Alice and Bob both have their own private and public key. For one, I mean, for one kind of exchange, you might see that, okay, there are less number of keys, more number of keys involved in symmetric, but asymmetric. But as and when the number of combinations increase, if you take the example of 10 people doing the communication, then only 20 keys would be required in asymmetric cryptography. If you use symmetric, it would be 45, right? Because everybody is just using two keys, public and private. And when Alice has to send the data to kind of Bob, she will use Bob's public key to encrypt the data. Public key is available. She can simply go ahead and download it from the internet and use it and encrypt the data, send it to Bob. Nobody else can decrypt that data. Public key cannot be used to decrypt the data for that was encrypted using Bob's private key. It can only be decrypted using Bob's private key, and that Bob will keep it securely and he will not leak it out. Performance, the slowness we already discussed, it is slow. Key management to some extent here also is a problem because finally the private key has to be kept securely, right? We also discussed about digital signature. So see, public private key cryptography and symmetric and asymmetric cryptography, that is more from the cryptography perspective, right? That protects the data, that maintains the integrity of the data, that the data goes from one place to the other. Digital signature is more to validate the authenticity of the message. It is not encryption. It uses cryptography, but it is not protecting the data. It kind of signs and gives a proof that this particular document is a genuine document. It has not been tampered, right? So in this case, when Alice has to send a digitally signed message to Bob, she will use her private key because it's her digital signature, right? So do not get confused between asymmetric and digital signature. A lot of people get confused. There, when she was sending a encrypted message to Bob, she was using Bob's public key. In this case, she's not sending an encrypted message. She's sending a digitally signed message, right, to Bob, confirming that the message has come from her, right? So in that case, she will use her private key, because just like your signature is your private thing, right? You only can sign that out. Your fingerprint is your private thing. Similarly, this private key that comes into digital signature case, that has to come from the person who's digitally signing it out. So she will sign it out, pass the message and the key to digital signature algorithm, that will generate a kind of a updated message. It will contain the message and it will also have the signature, right? Now when it goes to Bob, he will use public key of Alice to kind of verify. He doesn't need to decrypt here because it is just a message, right? It is not encrypted message. He just need to be sure that this message has not been tampered, right? So he will use her public key, Alice public key, and check whether signature is valid or not, right? So Alice would not be able to deny sending the message, as her private key is known only to her and she has signed using it. And it also ascertains authenticity, that the message has come from Alice to Bob, right? And it has not got tampered in between. If the message gets tampered, this signature is only valid for change the password. If the message gets tampered in between and somebody says do not change the password, then the signature will say that I'm not valid for this message, right? So when Bob tries to pass it through the message and the signature through this algorithm, along with the public key of Alice, it will say that signature is not valid because message has been tampered. We also discussed in the last class about firewall use cases, right? So firewall, like internal network, external network, monitoring the traffic and seeing what is being exchanged. So all that happens in the case of firewall. We also spoke the need for DMZ. Suppose that I'm running a company. I have my own intranet that is meant only for the employees. My company name is say harkey.com. Let's take that as an example, right? And I have a website also that is meant to be publicly exposed. So while I have my intranet, leave management software, procurement software that is meant only for the employee, my public website harkey.com, that is hosted in my network, that is supposed to be accessible and available to entire world, right? So what I'll do, I'll use two firewalls. I'll put my public website between both the firewall. The first firewall will protect the intranet, internal network, whereas the second firewall will protect the public website. And this concept is called as DMZ, dematerialized zone, right? So remember this also we discussed in the last session. We discussed about intrusion detection system. So this is more to kind of capabilities which will detect anomalous activity happening in the network, right? So if it sees that all of a sudden there is a flood of lot of requests coming from a certain IP, then IDS system will kind of detect that out and it will start logging it out. IPS is little better than IDS. It will not only detect and alert, it will also prevent. It will start blocking requests that is happening. Uh, IPS, a lot of people do not directly deploy because they do not want employees or even customers to get annoyed, because IPS can have false positives, right? It may wrongly detect something. So now I'll jump to application security, because the larger focus of today's talk is application security, right? So why application security? An organization that develops a software has already implemented strong network controls, right? Firewall, DMZ, IPS, and they're using, say, very strong cryptography to protect data both in transit and at rest. do they really need to take care of application security? What is the need? Because we have already done firewall, DMZ, IPS, antiviruses installed on all the system, right? And we are using making very good use of cryptography. Now, question is, do we really need to do anything in application security? The answer is yes, because application security risk cannot be completely prevented by network controls or cryptography, right? The network control that you're building, that is at your end, your system, right? But if you're building a client software, if you're building a server that is deployed, that is being accessed by the user, so many a times not all controls can be applied on the user input, and things like SQL injection cannot be prevented just because you're using HTTPS, right? So those things cannot be prevented because those are more of a error at the coding level. If you're not doing input validation for any data, network controls cannot prevent that out because somebody launches a cross-site scripting, creates a cross-site scripting payload, right? And that it sends to your customer. Your customer might get impacted because your website is susceptible to cross-site scripting attack. And when user clicks on that, some script will get executed on user machine and hamper it out. To mitigate such attacks and all OWSP top 10 and 25 attacks, one need to follow application security principles. So it becomes essential to understand that network cryptography controls, having a SOC team, all those are good. But for a lot of application vulnerabilities, you need to do good coding, you need to do good security software design, right? If you're not doing that out, then your application would be vulnerable and susceptible to attack. Now, developing secure application, there are two aspects of it, right? When you are designing the application, right? When like before going ahead with the coding, firstly you need to design that. Okay, this is my application. It will have XYZ modules. It will have a database connectivity. The database will not be publicly exposed. We will build so many internal APIs. We'll build so many external APIs for so and so purpose. We will keep the sensitive data encrypted. How are we going to hash the password? All those comes in the design. That has to be happening in the beginning of the project, right? Once the design has happened, then your development team will go ahead and execute that design, start writing code to meet all those design requirements, right? Now, if you're not taking care of security considerations right in the design phase and right in the coding phase, then you would kind of build a software that could be susceptible to attacks, right? So how can you build a software that is free from bugs and flaws? You can follow secure coding principles and secure design principles. So we'll talk briefly on those lines, right? An example is there that failing to do a server-side input validation is an example of security design flaw. And improperly implemented input validation logic is a security bug, right? So if you, as part of the design, you have not considered to do input validation at all. Let's take example that you have created a registration form, and as part of that registration form, you're accepting fields like email address, mobile number, and age, right? Let's take this as an example. Now, you are, as part of your design, you didn't consider that, okay, there should be a validation module that should be built that should ensure that the input is valid. That becomes a design flaw, right? Now, suppose that as part of the design, that input validation module existed, but while building the input validation, implementing it out, writing code for it, you didn't added appropriate measures to ensure that people are not allowed to enter mobile number more than 10 characters, right? Yeah, you are accepting alphanumeric characters or you're accepting script tags as part of the mobile number field, even though design said that input validation, but the developer just did very minimal input validation implementation, right? And they did input validation for email field and age field, but for mobile number, they missed it out, right? So that becomes more of a security bug because it was part of the design. As part of the implementation, you didn't honor it well. Now, when it comes to security design, you can, I mean, the two larger principles are there. Principle of least privilege that we have already discussed. The second one is principle of defense in depth, right? So as part of principle of defense in depth, the recommendation is to take a layered approach, build multiple layers of defenses that will prevent an attack from happening, right? So like initially when we discussed, we said that okay, network controls are already there, we have a firewall. Do not just rely on one security mechanism. Build input validation, right? Like on do input validation not just at the client side, do it at the server side as well. So that it's not just having one point of failure. And if one if some attacker is able to cross one line, there is another line of defense that is going to prevent an attack from happening. OWSP has a lot of detailed information on secured by design principle. So you can go through all that, and even IEEE has published papers on top 10 software security design flaws, right? You can go through that also. And even SANS has kind of good material to read about it. Now, if we start going each of them, it will itself become like 1.5 or 2 hour session. So I'm not going through all of them. I've just focused on the areas that Infosys certification require you to know. So that requires you to know principle of least privilege and principle of defense in depth, right? And principle of least privilege says that give as minimal principal privilege as possible. So an example, you can see that you may not have administrative privilege in your office computer because you can carry out your work without admin privilege, right? The laptop that I'm currently presenting with, right? I do not have admin privileges on that because that's my office laptop that I'm using for this session. And I do not have admin privilege for a legit reason because for normal activity that I'm working on, I don't need to have admin privilege. That is well monitored, right? Uh, when it comes to principle of defense in depth, SQL injection vulnerability can be mitigated by having the following controls. You can, from the coding implementation side, you can use a prepared statement. Do not directly accept input from the UI fields and directly embed that in the SQL query. Use a prepared statement and then utilize them for running the SQL query. The second difference that you can build is validating all the input. So do not just use the prepared statement, also validate the input. Set proper DB permission, right? I mean, you might feel that just using the prepared statement would prevent any SQL injection. Still, you are recommended and required to build multiple layer of defenses, right? Validate the input also, and also ensure that the DB permission is rightly set, right? If you're using the DB only for the read purpose, so do not allow the write permission from the server request that is coming, right? The SQL query that you're running, that should never be allowed to kind of write something to the DB or delete something from the DB. That's the essence of defense in depth. Building multi-layer security and multiple point of failures, defenses, multiple point of defenses. Okay, on secure coding side, there are a lot of materials available. Cert.org is my favorite. That kind of publishes like secure coding guidelines across all programming language. So cert.org, if you go, you will find it for almost all programming language. It helps in avoid introducing security bugs in the software. While design issues are called as security flaws, coding vulnerabilities are called as security bugs, right? Security professionals have analyzed previous attack targeting application and have discovered that most vulnerabilities have arisen from common coding errors, and the two renowned bodies are that are referenced for understanding the common coding errors are OWSP Top 10, right? Be it cross-site request forgery, be it cross-site scripting attack, server-side misconfiguration, use of a vulnerable third-party component, authentication bypass, weaker authorization, right? All those are covered in OWSP Top 10 and SANS 25 dangerous software errors. So these are reference for secure coding when it comes to learning more on the secure coding, but learning more on the security issues or bugs that arise from insecure coding. But if you want to get better as a developer, learning the secure coding practices, then my recommendation would be go to cert.org and read about secure coding principles for the specific programming language in which you have expertise. So as a developer, tester, code reviewer, your objective should be to ensure your application don't have any common security bugs. There are tools which are called as SAS tools, static application security testing tool or static code analysis tool. You can utilize them to quickly scan through millions line of code because you as a human you cannot cover like larger code base on in a short notice, right? But for any new code that is getting developed, you should continue doing the manual code review along with the static code analysis. And for any legacy critical code that does some critical operation, that also should go through manual code review along with the static code analysis. Cool. So moving on further, what are the now I'll switch gears, and this is beyond Infosys certification. I'll just quickly cover some more aspects so that you get a holistic understanding of application security domain, right? So these are some of the key ingredients of a successful security program in an organization. Now, when I'm talking about application security, it is not just about developing the code. It is all about post deployment. It has to be something gets deployed or released to production. After that, also you have to kind of maintain it, manage it. DevSecOps comes into picture, system administration comes into picture, end of life, all those comes into the application security umbrella that I'm talking about, right? So suppose that you have to run a program to ensure that whatever development activities is happening within your organization, right? For that, you want to start a security program to ensure that you have a holistic and full-fledged coverage. Then these are some of the key ingredients for that. Firstly, you should define what all development teams are required to do, what DevOps teams should be required to do, what happens at the release time, what happens at the deployment time, right? So that's called as STL program, right? Clearly defining what has to be done. Then you should have a vulnerability management team that looks over all the vulnerabilities that are getting identified, reported, and assesses them out. Then you should invest in people and training, right? You're building up a program, you need people to be educated and matured, so you should kind of get them trained. You should have an incident response team. If something goes wrong, if somebody identifies some vulnerability in your product, you should have a team that can cater to that and publish their details externally so that the external researcher, instead of going on social media, they can report it to the incident response team. Then you should utilize industry standard tool because doing things manually will slow you down. So you need to invest in industry standard tool. And finally, you should have people who are going to kind of enforce all these activities that you have defined, the policy that you have, and do a audit and check and confirm if people are really honoring that out or they are not following the principles that you have defined. So these are at very high level. All of them are a detailed topic to delve into. But if you want to create a security team who is going to focus on application security, the end-to-end life cycle of application, software, server, then these are the things that you should have within that group, right? Moving on, now I'll talk about different SDL activities. We spoke about some of the activities in the earlier slide, like design, secure design principles and secure coding principles. But that's not enough, right? A holistic application security program needs to have all these activities that you see here, right? So architecture and design review from security perspective, that should be done in the beginning, well before you start with the development. Then comes the threat modeling, right? You look into the architecture and design and you pinpoint the areas from where an attack can happen, where could be an entry point, what needs to be protected in the application, how well are the defenses or mitigations that are there in the application, right? So all that comes into threat modeling area. Then comes privacy and data protection, right? As part of all the applications that are kind of available today, people are gathering lot and lot of data from the customer end or the user end, and that data needs to be kept protected. So that also comes under in the purview of application security assessment. Static code analysis, SAST, running a scanner to see if the code is free from obvious vulnerability. Dynamic analysis, once a service or a particular feature is developed, running it out and testing it at runtime to see if it is having any vulnerabilities or not, right? We'll quickly run some exercise using Burp today so that you get some hang of dynamic analysis. Security testing and validation. So OWSP top 10, SANS 25, all of them give some guidance. So following that out, open source and third party library assessment. More and more organizations are using a lot of open source library to quickly make a release, because open source library that enables you to leverage something that is already existing, not to start writing code for everything, right? So it has a lot of advantages, but at the same time it requires diligence also. You cannot pick a open source library that is vulnerable, that is no longer being maintained, or the license puts a lot of restrictions for commercial usage, right? So all those has to be taken care, and that also comes under application security umbrella, right? So the moment you pick a open source library and ship it with your product or deploy on your server, you become responsible for its security, because open source library comes free, right? And if the publisher has stopped supporting it out, you are the one who brought it and took it to the customers for your organization, and the obligation would lie with you. So be very careful while using open source library. Secure coding practices and code review. So you should ensure that the developers that you have who are writing the code, they are aware of secure coding practices and they're doing manual code review. Just static code analysis is not enough, because static code analysis is an automated tool. It doesn't have contextual understanding for your organization, the kind of business that you are running, the intrinsic design and the domain specific requirement that your organization has. Static code analysis is more of an automated signature based tool, right? So that will not have that contextual understanding that humans will have. So do not feel that manual code review is not required. That should continue happening. Fuzzing or fuzz testing is more of testing any interface with varying set of input using a fuzzer that keeps mutating the inputs and passing that and bombarding the interface to see how many invalid inputs interface can accept. So that's more about fuzzing. Vulnerability scan is more to scan an infrastructure or an application to see its attack surface and find out if it is kind of secure enough, or is it having any entry points or a weak areas that needs to be protected. Penetration testing is more of a hacking approach or an adversarial approach, where you will kind of try to attack an application more like an external attacker, try to tear it apart, try to break it. That's about penetration testing. And then finally, the review of everything that was done. Is there any open risk assessment of that? Reporting, all those come under review and audit, right? So there could be more SDL activity, but I just want to give you some hang of some of this, some of them, right? And there are a lot of materials available on the internet that you can read about all these. Now we'll move to the quiz. So Swati, I'll request you to launch the quiz based on today's session that we had, and then we will delve into some hands-on session for using burp, and we will learn a bit about application proxy. So, people, these questions are very basic, and I'll request you to just see how well you can attempt it out. We're not tracking anything. There is absolute reputation. You can refute that you have answered it out, right? So feel free to attempt and utilize this for your own learning. And beyond this, we'll learn about Bob Suite, and we'll show you some of the exercises on Bob Suite.
It's a request, ladies. Please start participating.
Yeah, so we'll run the quiz for like another 6.5 minutes, right? So you have time and just go through the question and try to answer that out.
Out of 36, only 6 participants are participated in this quiz. So it's a request, kindly participate.
So Swati, we can give some more time for people to participate. Yeah, maybe we'll give 3 more minutes instead of 2 more minutes.
Sure, sure. Sir.
Thanks, Namrata and Hajirat, for completing it out. Thanks, Mansi, Surya, Madhuri, Uma for completing. Priya, Iksha as well, and Ranjita, Rashmi as well. Last 30 seconds, we'll stop after that. Thanks, Shruti. Last 15 seconds. So Swati, we can end it now
Sure.
with the current participation. It's fine. A lot of people joined in between as well. So cool. So let's quickly go through the questions. I think these are very basic and simple question. The certification that Infosys has, their application security chapter is not that complex. I think that is not that weighted also to from the question and that comes in the final exam. But yeah, I just try to get more questions so that you get more familiar with the concepts. So what is the primary benefit of employing defense in depth? Offers multiple chances to detect and stop attack. Perfect. So that's the right answer. Which of the following best describes the principle of least privilege? Users should be given only the privilege they need to. Perfect. So this is also right. Most of you have given the right answer. Which security control directly aligns with the principle of least privilege? Role-based access control. Yeah, that's the right answer. See, regular security audits may not. I mean, if you're not that can tell that you have not given the uh, right privileges, right? Or you can clean up some account, but that essentially doesn't focuses on principle of least privileges, right? That can help you in improving it out. That means that you have already done the mistake and you have not implemented it well. And usage of firewall, no, it will not help in principle of least privilege. RBAC is the thing. 89% of you have given the right answer. So moving to the next question. How does implementing encryption along with defense in depth, yeah, so for that serves as an additional layer to safeguard data. That's also correct. Align with defense and depth approach, right? So that's perfect answer because that does help in that. Which of the following best exemplifies defense of depth in action? Multiple layers, including firewall. Yes, that's the right answer. Perfectly, most of you have given. Periodic password update requirement, that just becomes one layer, right? But this is multiple layer. Unrestricted user access, again, that's one layer. But when you take this approach, it is multiple layer. Defense in depth about is all about having multiple layers of protection. How does segmentation of network contribute to defense in depth? Okay, so 64% of you have given the right answer by isolating critical data and services. So segmentation is more of isolation itself, right? Within an organization, you can have different network segmentation. Suppose that within an organization, you have three different sub BUs that are working, right? So there is a BU that focuses on finance, there is a BU that focuses on human resources, and then there is a third BU that focuses on technology development, right? All of them can have a different be in the different network to segment the data so that people from the finance view are not able to access anything on the HR side, or the people on the technology side or the development side cannot access the HR data, right? So that also is a layer of protection. The principle of least privilege helps address which type of security risk, insider threats. I was not hoping that these many people will answer it as right, but that's correct, right? Within an organization, we follow principle of least privilege, right? So that's a good thing to see that 62% of you have answered that rightly. A company wants to implement the defense and depth approach. Which of the following method would not be appropriate, right? So whoever has missed not, they would have given some other answer, right? But still 62% of you have given the right answer, using a single password for all system, right, and applications. That will not help. That's going to be more of a security risk, right? A system administrator needs to set up an account for a new team working on a sensitive project. Which practice aligns with the principle of least privilege? Setting up individual account with access only to the information necessary for each team member. Perfect. So that's the right answer. A software development company works with external contractors. What is the best way to implement the principle of least privilege in the scenario, right? This is a common thing, right? You will hire contractors who will work along with your own team, right? So again, in that case, what the system administrator does, assign contractor role specific access to necessary system through a controlled environment, right? They need to kind of make sure that they're not unnecessarily exposing things to contract members. Which of the following breaches the principle of least privilege? Maintaining default administrative access for all new employees, right? So that for sure kind of breaches the principle of least privilege. Assigning permission based on job role, yeah, that is good thing. It doesn't breach. Conducting periodic, this is also good. Providing temporary elevator, this is also good. Only this is the right answer because maintaining default administrative uh, uh, things for all new employees is something that can be abused. A hospital utilizes multiple applications to maintain patient record. What best practices ensure defense and depth in their system? So placing more stringent control on more sensitive application and using encryption for data at rest. Yeah, that's one thing. Ensuring all employees have access to all applications. No, this is not good. Using one strong firewall to protect all application and no other security layer. Yeah, the 76% of the people have given the right answer, so that's the right one. An application requires users to input their date of birth. Which input validation method ensures that the user do not enter future dates, right? Date range validation, that's right answer. You have given it rightly. When developing a medical application, the record patient vital signs such as temperature or pulse rate, which input validation approach is critical to ensure that correct data type and realistic range values, right? So validation from minimum and maximum value range, that's the right answer. And the last question was that when should input validation be applied in a software application? Only at the front end where user enters input, only at the back end, both at the front end and the back end, right? only when the software is being tested or debugged. So the right answer is both at the front end and the back end. So suppose that you are building an application which accepts the data in the browser. It's a website. User enters the data, right, and then submits it out. The data reaches to the server, so that's more of a backend. There also you should have the same validation, because in between user can use a proxy and bypass whatever he or she has entered in the browser and can kind of tamper it around, right? So it's essential, and we'll see a bit about that in the proxy exercise that we are going to learn. So I'll quickly take a pause to kind of see if you have a question, or should we proceed ahead to the next topic and then we can wait. So let me see if there is any question in the chat. Please share secure design principles links like OWSP and secure coding practice. Sure, I'll share that out post the session. I'll pass it to Swati and I'll ask her to send it to you people. Okay, so I'll move on because we have a lot more things to cover today, and we have 30 minutes. So we'll quickly move on, and then you can keep posting your question. As in, when you have doubts, you keep posting your questions, and I'll take a pause and ask that out. So now, as part of this exercise, we'll take a scenario, which is common scenario, right? And think of adversarial thinking, apply adversarial thinking, think more like an attacker or a hacker, right? This is a typical reset password flow that we are going to cover. And let's assume that there is no multi-factor authentication in this flow. It's a traditional old-time application. So let's take that as an example, and how are we going to protect that reset password flow without a multi-factor authentication, because the organization cannot afford to build a multi-factor authentication because of some technical limitation. So what happens in a typical reset password flow? You go ahead and kind of say that I want to reset my password. You are taken to reset your password flow. You enter your email address, right? And then a mail comes to you, right, with a link. And then uh, you are asked to enter a new password, right? And you click on reset my password, your password gets reset. So this is the typical flow. Now you are required to work along with a developer who's building this flow and ensure that there is no security risk or vulnerability involved. And he does a secure design as well as secure coding implementation of this flow, right? So what happens in a typical reset password flow? When you enter your email address and click on send email button, what happens behind the scenes, right? So this is the browser where you have opened this out, and this is a server where the data goes for the reset password. So you enter your email address and then click on send email button. A get request or a post request will get sent to the server, right? And it will say that uh, reset request.php. This is a PHP implementation, and username is john@demo.com. Let's see that that's the username that you have entered, right? Then the response will be, we have sent a password reset instruction to the following email address. That will be your the response coming back from the server. So this is how typically it works out. This is step one. You will see that in your UI. As far as the step two, right? You will get an email. You can see the email here that this is the dummy for demo.com reset password.php. Username is this, and request ID. It has a request ID, right? Now let's look into this example further. What could be the security consideration with this flow, right? So anybody who wants to unmute and talk that what they think could go wrong here. So this is the reset password flow. The email was sent to John Demo, whose real name is Ali Raj, right? And it was sent to their email address that they have registered, right? Can you bypass this? How are you going to bypass that? Suppose that this is how it has been implemented by the developer. So I'll give you
Ladies, we will wait for a while. I think some network glitch with Sandeep. Yeah,
Hey Swati, I'm
yeah,
back. My
yeah.
Zoom crashed out. I'm not sure what
Okay,
happened.
okay. No worries, no worries, Sandeep.
I was like, what happened all of a sudden? Sure. I'm back and I'll be back if Zoom crashes again. So just wait for me. Okay, so this is the flow that we're talking about, right? So now your goal is to kind of reset password for somebody else. You are John. You are having this John demo account, John's account. Your name is Ali Rach, right? So I mean, okay, some people are there. Okay, no questions in the chat, right? So if you see the request that the way it has come, right? It is over HTTPS perfectly fine. Username is there, reset password flow, right? This is the link that you have received. Now let's go back in this. Now we know the implementation. Let's go back in the flow. Now, as part of entering the email address, what I'll do, I'll enter your email address. Let's take example of Shruti. I'll enter Shruti's email address here, right? And I'll say that shruti@demo.com, right? The email will go to Shruti's email address account, which for which I do not have the password, right? But looking looking at this specific URL, I see that the request ID is in a specific format. It is double like 000, then it says 01 00001 triple zero 18 10 19. This sounds like a date, like it sounds like 18th October 2019, right? So it gives me some idea, and if today's date is 18th October 2019, right? I know that it is following a particular pattern, and for all the users, it might be that the request ID is going to be the same. So what I'll do, I'll copy this URL and change John at the rate demo.com to Shruti at the rate demo.com and play around with this request ID to guess the ID or try with multiple ID. Some of them might work out, right? Because it is guessable and it's not that complex, right? So I might be able to guess it out. So that becomes one problem, that the token that is being used for kind of uh, changing the password is guessable, right? And it is following a pattern also, like 0000181019. It could be if it was 181024, or if it was today's date also, like 19th of July 2024. With that also, I can make a sense. And I can try to guess it out or try to do a brute force attack because it is reset password. It is not going to lock me out. I have no impact on that. So I'll keep trying it out. And wherever the moment I see that, okay, you are taken to this screen, the previous screen, if we go back, right? The moment you are taken to this screen, new password, confirm new password, that means that I have the ability to change Shruti's password, right? So that becomes one problem, right? And that's how you should be looking at the thing. So how to mitigate this? The token, this is called as token here, that should be stronger and it should not be predictable or guessable, right? Let's move to the next step. What could be the security consideration with this flow, right? Where you are told to click on a link to reset a password. What else could be the security consideration in this specific flow? Should this link be allowed to be used multiple times, right? So you clicked on that link, resetted your password. Now somehow that link is known to your ISP because you clicked on that link and that is in your browser cache also. Suppose that you did this in a public laptop or in a shared computer. Somebody goes ahead and accesses that link, and again, the reset password option comes up. So you have to ensure that with whoever developer you are working with, they're not allowing this link to be used multiple times. So once this link is used, next time when somebody clicks on this link, it should say that the link has expired. So that becomes second security check in the reset password flow. Should this link be active forever, right? You did try to reset your password, but let's assume that you remembered your password and you never use that link. So there should be a time limit. This link should be valid only for few hours or a few minutes. Beyond that, this link should expire, right? So suppose that I forgot my password and I try forget password, the mail link gets sent. But then I think, okay, I remember my password now. Let me try it, and that works. I never use that link. That link is lying like that, and somebody all of a sudden tries that link, and that link is still active, right? And they are able to reset my password. So that should be one time use. So three requirements we got. First thing is that the token that is being used, as you see in this implementation, it is a stronger token, but it should be one time use, right? And it should have a validity. The token should not be valid forever, right? So these are some of the adversarial thinking. When you see any such implementation, you should start thinking how to bypass it out, right? So when I see any such flow as part of my usage of any banking application or any insurance provider application, my curious mind want to see whether they are secure or not. I do not do an attack or on them, but I just try to evaluate how strong is their token that they're using by looking at it, right? Uh, Now, the third step, you are taken to final reset password flow. What could be the potential implementation here by the developer, right? What could go wrong? So I'll just give like few seconds for you to think that what mistake can a developer make, right? In this flow, right? Let's assume that as part of account creation, you had certain security requirements. He has to honor those security requirements here as well, right? He should not start accepting weaker password. Like as a user, when I'm registering for the first time, I'm told that your password needs to be minimal 8 character. It should have special character. It should have numbers and alphanumeric. Now here, the same requirement needs to be enforced. Many a times developer forget to bring in those requirements here, right? So that also you should ensure that as part of this implementation that you're working along with the developer, that gets honored or built here. So this was a bit on the adversarial thinking that I wanted you people to understand, right? And start thinking how things could go wrong, right? The reset password flow, imagine that you're seeing that out. Try to see whether they are using secure token or not. Can you bypass it and do something malicious? Like in this case, I was trying to reset password for Shruti as an example we took, right? And if I'm successful, I can take over her account, right? So those all implementation, any application that is doing there, they should not be doing that out. They should build secure controls there. Now we'll learn a bit about application proxy. The Bob Suite is a proxy. Fiddler is a proxy. OWSP Z-Attack proxy is also a proxy. So we'll briefly touch base on what is a proxy. So this is a typical normal communication when proxy doesn't comes into picture. From mobile, from a tablet, from a laptop, MacBook, you send a request to the web server or a cloud server, and the request goes to the server, and then cloud will send back the response. There is no proxy in between. Direct communication happens. Now let's bring proxy into the picture. There is a proxy that's sitting between you and the server. A proxy has a IP. Proxy IP is configured in all the devices, right? And all the devices are also having a certificate of the proxy, right? So that certificate is installed on all these devices, and the request that originates from your device will firstly go to proxy. It would not be visible to a normal user that they are interacting with a proxy, but that the request will go to the proxy, and then the proxy will send that request to the server, and then the response also will take the same route. The response will come from the server to the proxy because that's what interacted with the server, and then proxy will send back the response to each of the devices. Now you will say that how does HTTPS work here, because HTTPS is more of a end-to-end encrypted, right? So in this case, yeah, it's end-to-end encrypted, right? You send a request, there is no proxy, and the device uses the certificate of the web server to have the HTTPS communication or the TLS communication that happens, that's encrypted. In this case, there are two TLS sessions that gets created. Its encryption is always from node to node, right? So in this case, first node is this, second node is this. So there is a one TLS tunnel that gets created, and that happens using the certificate of proxy, not the certificate of the web application. So you're not directly talking to the web application, you're talking to the proxy. The when the communication or the request reaches to the proxy, the proxy at the proxy that will get decrypted because you have trusted the public certificate of the proxy, and the proxy will decrypt using its own private key. The whole traffic will get decrypted here, and then the further communication with the web server that proxy does would be using the web server's public certificate, right? So there are two tunnels getting created. So there is a HTTPS tunnel that gets created from the device to the proxy, and then the second one from proxy to the web server. So TLS is not broken in a way, because the first set of the TLS communication that happens between the device and the proxy, and the second one that happens between the proxy and the device, right? So I hope this concept is clear, and that's why it is told that if you hand over your mobile or your laptop to some attacker and say that can you fix some issue in that, if they have malicious intent, what he or she can do potentially is kind of uh, route all your device traffic to go through a proxy that they are controlling, install a certificate on your device, right? And kind of kind of capture all the traffic that you're interacting, and that way you will end up losing a lot of your data. They can see what you're browsing, they can see all the data requests that you are sending. Yeah, that's man in the middle attack. Rightly said, Ranjita. So that's what is man in the middle attack that happens. So as part of man in the middle attack, it's not just the request, the response also, right? They can take away the token along with passing with you and then create a separate session at your end, or drop a packet and then use that session to log in as you, right? So that also can happen. So I hope this concept is clear, no doubt on this. Then we will move to Bob basics, right? So what I'll quickly do, I have Bob running on my end. I'll stop this from running. And I have requested all of you to install Bob Suite. I think that was a request that was sent last time by by Alakhya and Avneet, right? I have requested all of you to install, but I'll quickly ping the link also. Do not bother to install now if you have not already installed it out, right? And some of these links were already shared with Alakhya beyond the last session. So I'll share that again today so that you people have access to it. But that's the link that I've requested you people to install. You can, if you have already installed, you can go and launch Burp Suite Community Edition. The way I'm launching, I'm just doing a end-to-end demo so that you get an understanding of it. Right. It will say temporary project, no problem. Just click on next and click on start burp. Use burp defaults. Click on start burp. Okay, awesome. So Aarti Rashmi has confirmed that they have installed it. That's good. So it will go in this state, starting project, right? And you will be on this state. I'll just take a pause for all of you to come to this state, right? Okay, Madhuri, Mansi also have it installed, right? So Burp is more of a proxy. It will give you the same visibility that we saw here. You will be able to see what is getting exchanged, right? So I'll go back to the Burp window that is launched. I hope you are able to see my complete screen and Burp is also visible, right? Can someone confirm?
Yes, Sandeep.
Awesome. Cool. So go to the, it has a lot of tabs. Dashboard is the area where all the issues and findings will appear. So I'll not go a lot in detail at the moment because dashboard will not have any data. We've not started monitoring anything. Target is an area where you can define a target that has to be attacked. But remember, you should not be running an active attack on any application where you have not taken a prior permission, right? You need to be authorized, and it is considered illegal to launch an attack. You can test anything that is more of a playground that you have locally hosted or locally running. That's perfectly fine. But any commercial application that is there, you should not be launching a targeted attack on them, right? Let's go to the proxy tab. So target, as part of that, you can kind of define a target that you want to attack. The scope is here. So it will just focus on those targets only. It will not go to anything else. Will not go a little deeper into target because that's not interesting. For people who are enthusiastic, proxy is the area that will be more interesting. So go to the proxy tab quickly. And to cover all the aspects, we will run out of time. So I'll not cover all the aspects, right? To be wary of the time constraints that we have. So you see, intercept is off. You can keep it off, no problem from that perspective. You can click on open browser here. It should launch the browser on your system. It will launch a separate instance of browser that is already well integrated with proxy. So please confirm if most of you are able to launch browser without any errors. And if it is throwing error, no problem. You can fix those errors later. There are more ways to configure or use the already installed on your browser. That should work out. So Aarti confirms that the browser is launched, right? So thanks, Aarti. Uh, we'll use some demo website. I'll pass this website link to all of you in the chat. This is a website that belongs to IBM and it is meant for security learning, but still do not run a denial of service kind of attack. Do not bombard it with way too many things, right? Do we need to install Kali, Metasploitable? No, we're just doing a burp exercise. We're not doing anything on Kali, Linux, and all those. I have a slide to guide you on how to use that out. That will come later. But for this exercise, just launching the browser and using the burp proxy. That's it. Nothing beyond that. I just want you to get a hang of burp. So launch the browser. You are in intercept tab under proxy tab, right? Go to HTTP history and you will see that it has started monitoring the data that you are exchanging, right? So you can see this is the request on the left side. On the right side, you have the response. So let's analyze some of the things that have happened here. I am going slow because you people should follow what I'm doing and should be able to see that out, right? Or if you can just quickly see things in my screen itself and try these things, if you just see that the traffic is coming in HTTP history, you're all good. You can focus on my screen so that you don't get confused, right? And later you can try things because now you are comfortable with doing these things on your own, right? So you can try later at your end, learn from my screen that I'm sharing now. So assuming that you all are in the same screen and you have launched this, whatever traffic we generated in this browser instance, I just launched demo testfire.net. It led to two requests getting fired. One is for the load of the HTML content, and the second one is load for of an icon, right? It is an icon that it has loaded. So the first one, I'll just click on that. I'll see that the request was sent. It was HTTP get call to demo host is demo testfire.net, and these are the request header. These are called as request header. It is a get request, so it is not having any body, right? And this is the response on the right side that you are seeing. These are called as response header, and this is the response body that you are seeing, which is more of a HTML content. So whatever HTML that you are seeing, the color, the images, all is coming because of this HTML code that was sent by the server to the browser as part of this HTTP response. It said 200 OK. The status is 200 OK. There are several other HTTP status code. 500 series error is for the server side error. 400 is more from the client side error code. So read about them, right? But I'll not focus a lot in detail. If you see server is leaking, its footprint, it says that it is Apache Coinode version 1.1. So this should not be leaking server details to somebody outside. So this information is useless for any meaningful purpose. So this should be suppressed. It should not be leaking the server footprint, because now I know a bit more about the server, right? And I can research, okay, what are the attack, what are the exploits for Apache Coinode version 1.1, what vulnerability it is having, and you try to utilize the application. It is using session ID also, so that is also there, that also I get to know. It is setting a cookie, right? And it is using JSON ID. Now cookie is having HTTP only flag, right? So there are several HTTP cookie flags that are there, security flags. HTTP only is one of them. So I'll request you to read about the security flags and get an understanding of that. That will help you in application security assessment and web application. So when you go through OWSP top 10, read about different HTTP only flag. So HTTP only flag ensures that the cookie is only sent to HTTP request. For any other request like FTP request or any other request, it would not be sent. Secure only flag will ensure that the cookie is sent only for TLS or HTTPS request, not to HTTP request, right? So you can have two types of HTTP request. One could be over SSL or TLS with HTTPS. One could be with only HTTP, which is unencrypted. So if this had secure only flag set, the cookie would not be sent back when somebody requests it over HTTP, right? So these are the different flags. So this cookie is not having secure flags, and that would have got kind of highlighted here if you go to the dashboard, right? If dashboard is having any finding, it would have found that out. But I think this is the limited version, so it will not give those capabilities. It will not identify those issues, right? Because this is not a paid or commercial version. You have to manually identify all those things. But if you're using a commercial version of Bob Suite, it will automatically identify and highlight that in the dashboard. So that's one issue, that cookie, it is setting a cookie and cookie is not having secure only flag, but it is having HTTP only flag. That is good. It is having content type header, right? But charset is also set. That is good. So these all headers have a security implication and meaning. So read about content security policy header, read about content type header, read about cookie headers. All those are meaningful information, right? The second request is for fab icon. We do not need to focus on that. Any website will have a favorite icon. You can see this small world icon that you're seeing here, right? So this is not having any favorite icon. That's why it gave 404. That means it couldn't find the favorite icon. Each website has a favorite icon. If I go to rediff.com, this will lead to lot of requests getting generated here, but it will have a favorite icon. So I'll just quickly hit it out. You will see it will start buzzing with lot of requests, right? The moment I open Rediff icon, but it has a favorite icon, right? And wherever the favorite icon request was raised, it would have populated the R icon that you are seeing. That is a favorite icon, right? And it will generate a lot of noise here. You can see that there are like hundreds and hundreds of requests just for a single click. So this tool gives you all the insights, whatever happens behind the scenes that is normally not visible to us. So I'll close rediff.com because I'm not going to focus on that, and I'll delete all the requests. That was just to make you understand what is favorite icon, right? I'll delete all these requests by right clicking, selecting all of them, and say delete selected items. It will delete everything that were there. Now I'll move back to demo test player side, and I'll just click on sign in button here that you see, right? And do a sign in test and see what happens. So if I go here, you can see that it gave 200 OK response. Do login, and you can see that user ID and password both are visible, right? That's what is man in the middle attack. So whatever gets sent from the browser, if somebody is sitting in between, they will be able to see that out. in this case it is over HTTP. Still they are able to they would definitely be able to see it out. But even over HTTPS, if people are not encrypting the password in the browser, even with HTTPS request it would be visible. So if I take example of rediff.com, right, I'll click on their sign in button. I'm not doing any attack, I'm just doing a passive monitoring of this application, right? So I'll go to the bottom so that the latest request that I generate here, test@test.com, and let me put test1234 as the password, right? I'll just hit on sign in button and pick up the login request. So this is the login request that got sent to the server and server gave the response. It says wrong username and password, right? So if I go here, it should have the same response, right? You can see that this is part of the HTML response that came from the server, and the same thing gets rendered in the UI. Now let me see where is the username and password. So here you can see this is the username that I entered, test@test.com, and this is the password that I used. And this was a website which is HTTPS, right? It is not a HTTP website, it is HTTPS website with a valid certificate. Now the decryption happened because I trusted, or this browser trusts the certificate of the proxy, right? And the first communication that happens from this browser to the proxy, right? And that's how the decryption takes place that we discussed earlier, right? So I'll not go a lot in detail for that, but this is how a typical proxy works. This was just an way to bring this up to you. Now Burp has a lot more capabilities. It has a lot of tabs. You can mock. Let me go to the demo example only, right? So I'll delete other requests so that you do not get confused.
Uh, Sandeep, may I ask one question here?
Yes, go ahead.
Yeah, so if suppose we are on a system where this is already available and other person who is not aware, he or she is browsing like Facebook or anything, they are giving their credentials. So anybody on the system, they can see their password and that is also a way to get the credentials.
Yes, Rashmi. So if you're in a compromised system, right, definitely people can see it out. Now, like 5 years ago, Facebook, Gmail, and most of the applications were not encrypting the password at the browser. Now they have started encrypting it out, right? So that makes it difficult to see all the password for all the application, but there are still a lot of applications that are not encrypting the passwords at the browser. That was not existing earlier. They were all relying on TLS, but of late, a lot of people have started doing. So it's a risk because a lot of applications still will not do it out. How you can see whether the request is going through proxy? You can go and check the proxy settings of your system and see if the proxy is enabled, right? Similarly, on the mobile, you can go and check in the network settings if a proxy is configured. So that's the way you can check it out. So that's another reason why you should not do things sensitive operation in a public computer unless you are very sure that they are not compromising with your security.
Yeah.
I hope that answers your question, Rashmi.
Yes, yes. Yeah. Thank you, Sandeep.
Cool. Okay, so I'll quickly run one or two more exercise on demo and then we can open up for the question. So test and test. Okay, let me enter test@test.com. I'll generate a new request in the browser. So a new request got generated. You can see test@test.com, and the password that I entered was test. It did a 302 redirect, and here the response could have come that incorrect password, right? But this was the first request that got sent. I can use the repeater to send this request n number of time without going to this browser, right? Now let's see that I want to send this request with Shruti's email address. So I'll just say Shruti or Rashmi, any of your name, I can send it out. Rashmi@test.com, and I'll keep sending, right? And it will keep hitting the server, it will keep kind of sending that out, it will keep giving me the response back, right? So that's how it would be working. So you don't, and follow redirection, if you use, it will give you the redirection response also. This also would have failed, right? But you don't have to use the browser. As a attacker, as a hacker, the life is easier. You capture one request, beyond that you can use the Bob suite to keep sending varying set of input as part of using the Bob itself without requiring to go to the browser, right? So that becomes one thing that you can learn. We got session ID somewhere, right? Here we got a session ID. If you think that you want to try decrypting it out, you can send it to decoder and use a smart decode. If this is more of a something more like a base 64 encoding, you would be able to decode it out. This is not a base 64 encoding, so that's why decoding is not working. This is not hex also. But if it was using some obfuscation, then you can utilize decode to decode it out as well. So that capability also exists. There is an intruder via which you can launch an attack. You should not be launching attack unless you're authorized to do it out, right? Now for this, we will quickly do a attack. I'll not use Bob Suite for this. I'll just try to launch uh, like more of a attack on this application. Okay, let me enter this. Okay, let me run one more exercise. So you see that this is a client side validation. You must enter a valid password, right? Now, what happens if I send this request? Go to the same login request. Whether the server is saying that it is not to intruder, I have to send it to the repeater. Sorry. So I'll send it to the repeater. I can blank out the password here and then send it out, right? And then see whether the server also says the same thing. It should not say invalid password. It should say you entered a blank password. So it is not detecting that out. It would still be saying invalid only or incorrect password. I think invalid password would be the right thing that would be appearing in the browser. Yeah, so it is not detecting at least a blank password. It is saying if I enter test and test login, yeah, you must enter a valid username, right? So yeah, it is giving the same enter. You must enter a valid username. Right, so that's one exercise. Now I'll try to do a SQL injection here by using this as a payload. This is a SQL injection payload. The username I do not know, but let me try to do a SQL injection with this. I do not know the password. I'm just entering that this as a SQL injection payload and saying that username or 1 is equal to 1. That is always true. Beyond that, I'm just putting some SQL syntax and clicking on login, and you can see that login was successful. I have successfully logged into this system, right? And if I go and check this request in the Bob, right, it said found. It set a different cookie here, right? Now my interest would be to see if I can decode this cookie, so I can send it to decoder as well, and then see if it's smart decode work, or I can decode it as base 64. You can see that I have been able to decode this text, right? So this was using a base 64 encoding, and an attacker or the developer who implemented it, he or she didn't follow the proper security mechanism, and this is all decodable. So I'll leave all of you with all this learning and the burp exercise that we did to try at your own end, right? This session can go on for several hours, so I'll not spend that much of a time. These are some of the playground that I've shared earlier, and you people should have got it out. This is the lab setup that you're talking about. This is how you should be doing. On your laptop that you have, you should have a Kali VM, and then you can install as many lab as possible. For example, I put Metasploitable VM, right? These are in the same network as the Kali VM, so make sure that they are in the same network. Go ahead and power on both the VMs. The username password typically is Kali Kali for the Kali box, and for Metasploitable it will be MSF admin. Make sure Kali and Metasploitable both are in the same network, right? And This is what we have discussed earlier, how to build your profile in cybersecurity. Consider writing papers on cybersecurity topics. You have all your playground beyond me to continue your journey. So don't stop your learning journey here. Continue learning on all these aspects. See, cybersecurity is a domain where you can self-learn by utilizing all these available playgrounds that are there, right? And then based on your expertise learning, you can write papers on security topic. You can develop solutions related to cybersecurity to solve some problems. Like burp is a solution only, right? You can develop some solution to find some hacking mechanism, or to test if an application is vulnerable to certain type of attack. Develop a plugin. Participate in bug bounty. So bugcrowd and HackerOne are two popular platforms. Ethically reporting vulnerabilities by analyzing applications without doing a offensive attack on them. Conducting training at our popular conferences, or start creating content on YouTube or different media. Filing CVs, common vulnerability enumeration scores for a vulnerability that you identify in popular applications. It could be Firefox, it could be Zoom meeting that we are taking. They could have potentially have vulnerabilities. So if you have become expert, then you can start applying that out. You will get expertise by going through these playgrounds, by reading through different attacks that happen, right? So continue that reading. Thinking of approaches for solving critical cybersecurity problem and filing patents and CVs, right? We discussed about this adversarial thinking exercise, right? That should sow in seed to look into any space and identify where could things go wrong, and try to see how to prevent that from happening, right? And these are some of the books that you can continue your learning journey. We can open up for questions, whatever you have now, but that's all I had for covering today. And let me know if you want me to go back to any slide. I'm more than happy to do that out. You can unmute yourself, ask question, or you can put that in the chat.
Sandeep, can you show the SQL injection one more time, please?
Sure, I can go do that. Oh, the burp got closed. Just give me a minute. So burp little requires good compute and memory. So make sure that your laptop has that out.
Sandeep, while explaining about burp in that, you have explained about some security flag and some other things we need to look into. Can you repeat that? Those.
Sure. Yes, security
Thank you.
flags, security headers, right? So if you just search for security headers, Mozilla has very good write-up. So you can read from either securityheaders.com or even OWSP website, and like Mozilla has very good write-up on security headers or HTTP headers. So if I just search for HTTP headers, sorry, Mozilla documentation is very good. But if you want to learn from security aspects, then go to securityheaders.com or OWSP top 10, right? So here you can enter any website and analyze their security headers as well, right? So I can enter this website and then see their security headers. This is more for demo, right? So that I'll analyze. You can see that they put it as F, and they say that content security policy is missing. But what is content security policy? That learning you can gain from this page. XSS protection header is kind of deprecated. X-frame options, referrer policy, these are all separate header. Content type that you saw, right? This is a security header. Set cookies a security header. Uh, strict transport security is a security header. Expect CT, content security policies, more of a very big security header. It has a lot of capabilities. So content security policy does a lot of things. I can take an entire session just on content security policy. So I'll not go a lot in detail, but these are all separate security headers. I can put that in the chat for your own learning. You can read about it.
Sure. Thank you. Thank you very much.
Yes. So this is the SQL injection payload that somebody wanted to see. But my recommendation would be, now you are interested in cybersecurity domain, create your lab. If you have a laptop, start utilizing that learning. There are free softwares that you can utilize. Right, Kali Linux is free. Metasploitable VM that you can use as a target attack target, that is free. Oracle VirtualBox is freely available. I think even VMware gets their player for free, right, with limited capabilities that you can utilize. Create the lab setup and start learning, right? This kind of lab setup, you just need to ensure that both of these are in the same network, right? And all these are different playground, like Security Shepherd, UShop. These all are different kind of applications that you can utilize for all your learning. So continue with that learning journey, and then once you are very comfortable with this, start participating in bug bounties, start talking about this, start creating basic content as a content writer if you want to work, right? To educate people on how to do SQL injection, create content on that. You can earn money from that. You can create your profile also from that, right? So those all for sure will help. Start participating in bug bounties also. So that's what would be my ask and recommendation. Any other questions or anything where you want me to go back to? So if all is good, then we can stop here, and that brings us to the end of the all the sessions that we're having. And it was for sure good journey for me as well, because most of the content that I prepared, I'll say that 75% of the content I had to prepare, because I've created sessions on cybersecurity on a larger topics, but this was just catering to the Infosys certification requirement. So I just wanted to stay along with that. So Rashmi, I'm not sure if I'm allowed to share my LinkedIn profile. Har Shakti doesn't recommends that, but you have learned the basics of cybersecurity. If you can go on LinkedIn, you should be able to find me there. You should be able to find that out there as well. You have my full name as part of the Zoom call, so I'll let you people able to try a bit of hacking skills or searching skills, apply a bit of more of a security skills to find me on LinkedIn. It won't be that difficult. I'm based out of Bangalore, so you should be able to find out. And you know that I've worked for McAfee in past. So thanks a lot for all your feedback, and please do continue your journey and join for the session on 23rd. You will get inspired by all the good work that Aarti has done as part of her journey, right? Her journey has been inspirational, and she is one of the topmost women leaders that we have at McAfee in my previous organization. So Swati, we have come to the end of the session. You can take over and kind of wrap it up.
Sure, Sandeep. So, Sandeep, thank you so much for this informative and wonderful session. And I hope the session is very informative for all the participants, as you are getting so many replies, so many, I can say, compliments in the chat box.
Yeah.
So, ladies, your next session, like it was the last session with Sandeep, and your iconic leader session will be on 23rd July. So, kindly join on time. And thank you so much, everyone, for joining in the session. Thank you so much, Sandeep. Thank you so much.
Thanks everyone. Have a great day and happy learning. Take care.
Yeah.